Polarization. In the year 1865, Maxwell proposed electromagnetic wave theory. According to this theory, light is an electromagnetic wave. It consists of vibrations of electric field and magnetic field in a direction perpendicular to the direction of propagation. Also, the vibrations of electric field and magnetic fields are confined to two different planes that are mutually perpendicular to each other. It was proved that electric field vibrations are responsible for the vision. Therefore, vibration of light means electric field vibrations. If we neglect the vibrations of magnetic field, the representation becomes simpler. Now, the electromagnetic wave will look like a pure transverse wave. Every vibrations will have a particular plane of oscillation. The oscillation can be in this direction, and even in this direction. We know that electromagnetic waves are produced by excited atoms. A particular atom may produce electric field vibrations in this direction. Its neighbor may produce vibrations in this direction. Similarly, different atoms of a material can produce vibrations in variety of directions. Due to this, a common source of light like incandescent bulb, candle flame, fluorescent lamp, etc. emit light that have electric field vibrations in a number of directions. This type of light beam which has vibrations in more than one plane is called unpolarized light. Similarly, a light beam which has vibrations in only one plane is called polarized light. The electric field vectors in the unpolarized light can be resolved into vertical and horizontal components. Now, this is the simpler way of representing an unpolarized light. However, this is only a front view of the wave. On the side view, the wave is represented in this way. Here, the arrow represents vibrations in the plane of the paper and the dots represent the vibrations in the direction perpendicular to the plane of the paper. Polarization of light. When an unpolarized light is allowed to pass through a Polaroid, let's call it as a polarizer. Out of all the vibrations of light, only those vibrations pass through the crystal which have vibrations parallel to the crystallographic axis. Here, the crystallographic axis is represented by the dotted line. Now, the emerging light is a plane polarized light. It contains vibrations in only one plane. The phenomenon of restricting the vibrations of light to particular plane perpendicular to the propagation of light is called polarization of light. Now, let us learn about two important terms used in this topic. One, plane of vibration. The plane ABCD here that contains vibrations of the plane polarized light is called plane of vibrations. Number 2, plane of polarization. The plane PQRS perpendicular to the plane of vibration is called plane of polarization. It is also the plane in which there is no vibration. E0 is the intensity of the unpolarized light. Then the intensity of the polarized light I coming out of the Polaroid is given by I is equal to I0 by 2. Now, if we pass this plane polarized light through another Polaroid, we will call this as analyzer. If the pass axis of polarizer is parallel to the pass axis of analyzer, the emergent light will have no change in intensity. That is, when theta is equal to 0 degree or 180 degree, the intensity is maximum. That is, I is equal to I naught by 2. I naught is the maximum intensity. If the analyzer is rotated by an angle theta, then the intensity of the emergent light decreases. When the pass axis of the analyzer is perpendicular to the pass axis of the polarizer, then no light will be transmitted out of the analyzer. That is, when theta is equal to 90 degree, then the emergent intensity I is equal to 0. Now, Malus law states that when a completely plane polarized light is incident on an analyzer, the intensity of emergent light varies as the square of the cosine of the angle between the polarizer and analyzer. That is, I is equal to I naught cos square theta. Polarization by reflection. The simplest method to produce plane polarized light is by reflection. This method was first discovered by Malus in the year 1808. It was found that when an unpolarized light is incident on a surface of transparent medium like water or glass, some part of the light got reflected and the rest got refracted through the material. Here, the straight arrows represent vibrations perpendicular to the plane of the surface, and the dots represent vibrations parallel to the surface. Now, if we observe the reflected light, we can see that it contains more number of dots than the arrows, which means that the reflected ray is partially polarized. Similarly, if we look at the refracted ray, we can see that it is almost unpolarized. It was found that as the angle of incidence changed, the degree of polarization of the reflected ray also changed. Then, at a particular angle of incidence, the reflected ray is completely plane polarized and the vibrations are parallel to the surface of water. This particular angle is called Brewster's angle or the polarizing angle. Brewster's law states that when a light is incident at polarizing angle theta p at the interface of a transparent medium, the refractive index of the medium with respect to the surrounding medium is equal to the tangent of polarizing angle. That is, n is equal to tan theta p, where n is the refractive index of the medium with respect to the surrounding medium. Using Brewster's law, we can calculate the polarizing angle of a medium whose refractive index is known. For example, for glass whose refractive index is 1.5, the polarizing angle is found to be 56.3 degree when the glass is surrounded by air. Similarly, when water is surrounded by air, if the refractive index of water is taken to be 1.33, it is found that the polarizing angle for water is equal to 53 degree. Polarization by scattering. Just as unpolarized light can be partially polarized by reflection, it can also be polarized by scattering. This is also known as Rayleigh scattering. Since light waves are electromagnetic in nature, they will vibrate the electrons of air molecules perpendicular to the direction in which they are traveling. The electrons then produce radiation that is polarized perpendicular to the direction of the ray. However, there is no polarization parallel to original direction of the incident light. The light perpendicular to the original ray is completely plane polarized. In all other direction, the light scattered by the air molecules will be partially polarized.